Good morning everyone, it's John here. Today we're on part 2 of our upgrade program for the Zyao X12 Electric Scooter, which is fitted with twin 60 volt 20 amp hour batteries. Now, yesterday on this particular battery pack we replaced the standard BMS with the Daly Smart BMS. And that went well. That's all fitted and working and connected via the app to our phone, everything working perfectly. Today we're now going to work on the second of the 2 battery packs, which is a slightly more difficult proposition because the BMS on this is actually runs the length of the battery pack and is soldered directly to the individual cell groups. So we need to do slightly more work on this to remove the old BMS and fit the sensor lead to attach the new Daly Blue Series Smart BMS, which has also got a built-in active battery management system. So we're going to take this battery out, we're going to get it on the workbench, take it apart and have a look inside. And there she is, one heavy 60 volt 20 amp hour battery pack, which now we're going to take apart and see how we can fit that blue Daly Smart BMS with active battery management system. With the 60 volt 20 amp hour battery pack on the workbench, we now have to remove all the screws around the case, remove the case and actually get to the battery pack which is sat inside. And once we've removed the old BMS, we're going to be fitting the new Daly Smart BMS with active battery management system built in. And also built in is a Bluetooth transmitter receiver which can connect to your mobile phone or your PC and display all the various settings and parameters to control your BMS in future once it's all powered up and installed. So we're going to get to work and undo the case and have a look inside and start the job of removing the original factory fitted BMS. Having undone all the screws, we can now lift off the outer case and you'll see the charge and power port is connected by an XT60 plug to the battery. So we'll unplug that, remove the top case, and now the battery is sat inside the outer case in its own inner protective case. So the next thing is we'll lift the battery out and we'll have a look inside here. So at this point in the proceedings, I should point out that on this battery pack about 4 years ago, we did have one single battery cell which went faulty. And unfortunately, as I lift the outer case off to reveal the pack inside, fortunately, the individual cells in each string aren't glued into place. So I was able to identify the faulty battery, disconnect it from the string, slide it out and slide in the new 18650. And that's been absolutely fine. It's worked fine for the last 4 years. So that's why you can see this pack has actually been apart before. So without further ado, we'll lift out the battery pack from its protective box, take off the shrink wrap, and we'll have a look inside. With the battery pack now removed from its outer housing, you can see the first problem we have, and that is that the factory fitted original BMS is one long PC board which is connected directly to the 16 strings of this 60 volt 20 amp hour battery pack. So we're going to have to cut each of the tabs on the 16 strings running along both sides of the BMS board. We're going to have to desolder the main positive connection at one end of the PC board up here, which are soldered connections, and the battery negative connection over here, another solder connection, so we can desolder those. But the other connections on the tabs here are spot welded, so we'll have to cut the tabs. And then once we've done that, we can connect the sensor lead kit, the blue sensor lead kit for the new BMS to connect it all into place. So the first thing is the big job of actually taking off this original BMS. So what we've had to do here on this battery pack is actually use a screwdriver and sort of break the tabs. There was no other way of doing it. I tried drilling the welds out with a drill, but the weld's actually very hard and the tab is very soft, so it's quite easily accomplished to break the tab on all the sensor connections to the BMS board. And now we can lift this out. So that's the factory BMS. This leaves the Samsung 18650 pack. Now with all the connector tabs on the various strings, which we can solder the sensor leads to connect to the new Daly Smart BMS. So the next thing is we'll just get the pack out with the sensor leads, check we've got them all located correctly, and then we'll get soldering those onto the tabs. It's been a bit of a trial this, but now we've removed the original BMS from the battery pack, and I've just finished pretty much installing the sensor leads that will connect to the new Daly Smart BMS with the active battery manager. So if we have a look down here, you can see the battery pack with the nest of wires for the sensor lead that will plug into the new BMS. And the last thing we have to do is the main battery positive lead here needs to be soldered on to the last connection on the battery pack, the main battery positive. And when we measure between the 2 points here and here, we get the full voltage of the cell, which is currently, or the pack, which is currently running at 64 volts. So that's the last connection we need to make now. So we're just going to solder this on, and then we can check the electrics to make sure that everything is correct before we start plugging in the BMS and checking it's working. So taking our soldering iron, our 100 watt soldering iron, we'll just a little bit of solder on the bit, and now we're going to tin up this wire here. Make sure it's well coated in solder before we attempt to solder it to the last tab on the battery. It's a nice lot of solder on there, so it drops on nicely, and we'll get this connected up. We'll make sure everything's connected correctly and check the voltages across the terminal to make sure they run sequentially from the first string to the last string. So once we've done that, we can then plug in and get testing on the battery pack connected to the controller and the bike. Now the final check on the cell voltages. We're going to make sure that the plug has been wired in the right sequence, and that we should each cell string go up by approximately 4 volts. So we'll put the negative probe onto the main battery negative, and we'll go up a step at a time. First string 4 volts, up to 8 volts 2 strings, 12 volts for 3 strings, 16 volts for 4 strings, 20 volts for 5 strings, 24 volts for 6 strings, 28 volts for 7 strings, 32 volts for 8 strings, 36 volt for 9 strings, 40 volts for 10 strings, 44 volts for 11 strings, 48 volts for 12 strings, 52 volts for 13 strings, 56 volts for 14 strings, 60 volts for 15 strings, 64 volts for the final 16 strings. So everything is wired in the correct sequence on the sensor plug, so that is now safe to plug in to the BMS when we're ready, after we've tidied all the wiring up. Now we've got the battery pack back inside the shrink wrapped wrapping, and we can now check before we do the final installation that the BMS is all working correctly. So let's have a look. We'll plug it in, do some measurements on the voltmeter and see if it's all working perfectly. So let's have a little look down here. So we can see here the battery pack and the BMS. So first thing, I've connected the main battery minus wire to the battery minus on the BMS. We've connected the temperature sensors which are needed for the BMS to work. And now the first thing is we have to plug in the sensor plug, making sure the total negative is lined up with the total negative end. We plug that in. Very tight fit this. Push that right home onto the BMS. That's it. And now we put the battery plus connector for the BMS into position. It's in. And we've got a green LED showing everything looking good on the BMS. That's great news. So that's all looking very positive. So we'll get the digital voltmeter. Let's have a look here. Now, what we should see here is 64 volts from the battery positive to the B minus. Yeah, 64 volts. And when we go to the P minus, so we go on the other side of the BMS after the information has been processed in the BMS, it should have the same voltage coming out. Hallelujah, it's exactly the same. So that means the BMS is connected successfully, it's processing the information, and it's sending 64 volts out the other side, exactly the same as the input. So that is absolutely excellent. So now we can finalise the installation of the pack back into the box, fitting in the BMS securely in the packaging, and then we can get testing on the scooter. But now it's all looking very good, everything working correctly. We can now connect the P minus wire, which goes to the plug, which will plug into the controller and set the whole thing working. Now we know this is 100%. Excellent news. So now we have the Smart BMS all connected up, finished properly, everything working inside the plastic box. And now we're just going to put in some padding to make sure it stays nice and firmly in place without rattling around, and put the cover on, put it back in the main box and get it connected up onto the scooter. So everything going very well. So we'll get this packed away, connected up and check it out. With the BMS powered up and connected to the Daly app on your mobile device, this is a brief look at how it will appear on your screen. The first page here is the status display screen, which gives you an overview of the system. And then when you go into the parameter settings, there are lots of different things you can set and customize to your exact needs, but we'll go into these more thoroughly later. So here we are, the Zyao X12 scooter, 60 volt, 20 amp hour battery, all fitted and sorted with its new Daly Smart BMS with active battery balancer, all working perfectly. So now we've got both 60-volt batteries with Daly Smart BMSs, one with the active battery balancer and one without, which we can add as a separate module if we want later. So now we test it out, switch on the main power, turn on the start button, and here we have 63 volts showing, and there she is all powered up, ready to go. Touch the throttle, away we go. So we'll give it a proper road test later.